Hello everyone, welcome back to the Marsmatics. In this video, I'm going to give you some rules that would make bearing impossible to mess up. So in this video, I'll show you some hacks that will solve the questions of the bearings easily from these hacks. By the end of this video, you'll be navigating these exam paper questions like a pro. If you're ready to master IGCSE math, hit that subscribe button, grab your protector and let's get to that. Starting here, this is a trigonometry. It shows a bearing. Bearing is the application of a trigonometry. We have to apply some techniques of the trigonometry to solve the bearings question. To start with that, what is the bearing? Bearing is basically some kind of an angle that we measure from the start for the north. It means if you have a line going through that and you measure a bearing from any point of that, it should have a north of that, because we know the north is straight up, and through that north you have to measure the angle from the north. And we know that we always measure the angle starting from a vertical line pointing. Vertical line means going upwards towards the north. Second point shows that the clockwise direction, we never measure to the left. It means we have to always measure our angle from the north and going towards the clockwise direction to any point. So it means that's a clockwise direction. If you're measuring the angle from the north towards the clockwise of any line, that would show you the bearing of that point. Now, the third point says the three figure rule. That's a very important one. Many people do the mistake with that, they write out the two figure, when they're writing the bearing, they write out with the two figures, but they lose some marks through that. This is a very important thing you should know, that bearing must have 3 digits. It means if you got some answer for the bearing that is 60 degrees, so you don't have to write directly 60 degrees. For writing the bearing, we write it here is 060 degrees. It means that would be into a 3 figure. But if you get the answer as like 120 degrees, that would remain as 120, because we have to show the 3 figures for that. That's a very important thing. Now there's another important hack. That hack would be the most important for going the back bearing hack. So for checking that, if we have got the bearing, suppose we are having a line, we can say that above is given a line which is AB. So if we got the bearing from A to B, and exam question says that you are finding the bearing, back bearing from B to A. We already know the bearing A to B. Now we are going to get backwards from bearing B to A. Then we can use this shortcut. That's a very important in every question. You have to normally use this type of shortcuts, that we note the bearing A to B. If that bearing angle is less than 180 degrees, if that would be less than 180 degrees, to get the back bearing B to A, we have to add 180 degrees to that bearing. That was already less than 180. So that's first one. And if that bearing A to B is greater than 180, like if it's 210 degrees, so then to get the back bearing B to A, we have to subtract 180 degrees from that. That's an important part. So I'll show you that practically onto some line as well. If we have this given, you can see there's a PQ line, and we are going to get the bearing Q from P. Remember, if you're given from P means towards the P you have to start from. And now if that's a north of the P, we know the north of the P. To get the bearing from P, we know we have to start it to the clockwise towards the line that is joining to Q. So that if you see that angle would be the bearing of that line, like the bearing from Q, like Q from the P, because we are going to check from P towards the Q. That would be the bearing. And if we say that this angle supposedly is 75 degrees, as showing, we'll say that would be a 75 degrees, but it's like more than that. We know it would be more than, I guess, 90 degrees as well. Just I'm taking as an example. Now to check the bearing P from Q means now you have to draw a north on the Q. The north is now on the Q, and you'll be measuring the angle. To measure the angle, we have to again start clockwise to that, and you have to go to the line that is already joining the Q. To get the back bearing from Q to P, we have to do is the step I told you about the back bearing here. If the angle is less than 180 degrees, that's 75 degrees, you have to add 180 degrees to that. So if you add 180 degrees, add with 75 degrees, that would give you 255 degrees. It means to get directly the back bearing, we don't have to use the protector for that. You can just find out one angle, and after finding the one angle, you can just subtract it from 180 degrees or add it with 180 degrees. Because that 75 degrees is less than 180, we have to add it to the 180 degrees, and you'll get the back bearing from P from Q. Okay, so that's basically the concept of basic concept of the bearing that you can apply. The back bearing hack is a very important thing. Secondly, the 3 figure, you don't have to mess with that. And the clockwise direction, you should know, always measure the clockwise. Do not go anti-clockwise, do not go anywhere. And we have to start the measuring from the north. First of all, starting the question, take the north. Always make the north. After making the north, then go clockwise and see out any point where you are measuring. You'll get the bearing. That would be the bearing for that. Moving towards the questions of the bearings, these are basically the past paper questions that are taken from some previous years. Question number 1, it says that ABC are 3 towns. We have been given point A, then a point B, and there's a point C. There are 3 towns of the bearing, and the bearings from C from the A. It means from the north of the A, you are going to get the bearing or till the point C, till the line C, which is 114 degrees. So the bearing from A to C is given. Now, B is due south of A. We have been given B is due south. It means B is the direct a straight line. You should know about the compass that we have east on the right, then west, after that north, and then south. So we know due south is directly straight line, so that would make you a straight line. About that, there's a B over here on the south of the A. Now, and then they have given AC equals to BC. This is the AC, above and BC are both given. They are equals to each other. It means they are making a isosceles triangle. What we are calculating the bearing of B from C. Remember, this from C is a very important thing. It means from C, so you have to start from C. As we have to start from C, the first step would be you have to make a north on the C. Now we get the north, and we are getting the bearing from C to B. It means you have to start clockwise and you have to get to the line B from where it's joining to the line B, point B. So therefore, this is the angle we have to calculate, and that would be the bearing from C to B. To get that, we cannot get it directly. Therefore, we have to apply some techniques. The main part here is that B is south of A. It means they are a straight line because it's going downwards. North and south are a straight line on that. It would make a total angle over here from B to A is 180 degrees. As we know, this is a 180 degrees as a semicircle. So to get that thing, we can get the small angle inside this triangle. And for getting that, we know there's a straight line, 114 degrees is given. So 180 degrees subtract with 114 degrees. After subtracting, we'll get the answer. That would be 66 degrees. And this 66 degrees shows that this is the small angle inside here for the triangle. And therefore, we know this is an isosceles. It means if this angle is equal, the other angle should also be 66 degrees, right? So if that's one is 66 degrees, what we'll try to get it? We try to get the small angle here. And we can apply the rules of the triangle. That would be 180, subtract these both angles. We'll get directly the smaller angle because the interior angle total for a triangle is 180 degrees. And when we subtract them both, what we'll be getting here is 54 degrees. The smaller angle is 54 degrees. Now, we are finding out is this angle from C to B. But we know we cannot get it directly. Therefore, we got this small angle. We'll try to get this another angle over here. After getting this another angle, we know the whole 360 is completed. So the total angle over here is 360. You can subtract these smaller angles and you'll be the remaining angle would be the bearing from C to B, right? So now to get this angle, what we'll be doing here is we'll be applying a very important technique that would be a parallel angle technique. And the parallel angle, we know the parallel line technique. Basically, you see this north is going above and this north is going also above. So they are both parallel lines, right? But whenever we are going with the two parallel lines, the important part in that is the angles, the interior angles. These are basically the co-interior angles. The co-interior angles are always equals to 180 degree. So these are co-interior angles equals to 180 degrees. We have been again given 114 degrees is here, right? So 114, we can just take it out any angle, subtract from 180 degrees, we'll be getting the answer. It means that would be 66 degrees. And that's a co-interior angle property. Otherwise, you can use another technique here. You can see this technique. When there are two parallel lines going, you can make a Z on that. That is alternate angle property from here. This alternate with the green you can see that's an alternate angle property. If this angle is 66, the other angle should also be 66. Now we got this one as 66, this one as 54. What we'll do here is the total over here from this north of that to the north again is going to be 360. So then 360 degrees subtract with 66 degrees subtract with 54. We subtract both the degrees out, the angles out, and the remaining would be from north of C to the B, and that would be the bearing from C to B. So 360 subtract 54 subtract 66. That would give us 240 degrees. It means the angle from this C of the north towards the line B is 240 degrees. That is the bearing, and the solution for that is given. Question number 2. That's another past paper question, which is a very important question in terms of the paper point of view. If you see that a lighthouse L, there's given a lighthouse which is L is 3.2 kilometer due west of a point P. So there's a point P which is west of 3.2 kilometer on that. And then there is a ship S which is 1.9 kilometer due north. So this south is basically, the ship S is basically 1.9 kilometers to the north, because north is a vertically upwards to the lighthouse L. Now when we check this out, calculate the size of the angle marked X. We are getting this angle marked X in that. In this question we see that there is simply a right angle triangle is given. Remember, in every question there is not necessary it's going to be bearing always. There can be different trigonometric techniques that could be applied to that to solve with the question. In this technique we saw this is a right angle triangle, so we'll think about some different techniques of trigonometry. What we can apply here is we can apply with the right angle techniques. That would be SOHCAHTOA techniques, sine, cos and tan techniques to get the angle, because we are given two sides of the right angle triangle. To get that, if you are having any confusion with those techniques, there's a video on the channel. You can go through that as well to make your confusions all clear. We know if there's an angle given here, so the opposite side to that would be named as an opposite, because the included angle we are taking is an X, and the remaining side would be an adjacent. To apply the techniques, we have to memorize the formulas. That was a tan techniques, because tan is the form, the angle, like the formula for tan is opposite by adjacent. That is the SOHCAHTOA techniques, because TOA involves TOA. From T it's a tan, O is the opposite dividing by the adjacent. To solve that, just we'll be applying this technique. So tan of the angle, which is an X, equals to opposite by adjacent. We already know, because the angle X is here, the opposite is 1.9, dividing that by 3.2. That's an adjacent over here. To solve this, what we'll be just doing, we'll taking the tan to the other side. So X equals to tan inverse. Remember, whenever you are taking from the angle, you are making the tan alone. So you have to take it with the inverse of the other side. And 1.9 divided by 3.2 simply. Now we'll be applying it onto the calculator. To apply that onto the calculator, what we'll be do here is tan inverse, putting the inverse, and then 1.9 divided by 3.2. After solving this out, what we'll get here is X equals to 30.69 degrees. Remember, if there's a 69, we are getting it to the 3 significant figure. Remember that 3 significant figure means the 3 non-zero numbers. Like the first 3 numbers you have to get to there. Because there's a many numbers, so you'll just stick to the 3 numbers. So 30 point, and then that would be a 7, because 69 gets to a 7. And when we know that there is a 0 between the two the significant figures, the 0 also becomes significant. So that would be the solution for this question. Now, moving towards part B, find the bearing of the port P from the shape S. Now what we are doing is from the shape S. It means starting from the shape S over here. To get it, we have to start from the S, north of the S, and get to the P from the bearing of P. So the line P is S and going towards the P. It means this is the bearing angle we are going to find out. So it means the angle theta which we are finding out is this one. To get from S to the P, again into the 3 significant figures, what we'll be doing here is we'll be applying some different techniques. To apply the different techniques, we know there's a straight line because the L is also the north, and there is a right angle triangle. To get that thing, we'll just take out this small angle and there's a straight line. If we get the small angle inside the triangle, what will be remain with the other angles? Because that's a straight line, you can subtract it from 180 degrees and you'll get the answer. To get that angle, we already know one is the 90 degrees angle inside a triangle, and the other angle x we have already figured out, which is 30.7. So you'll be applying 180 degrees, subtract with the 90 degrees, and then subtract with 30.7 degrees again. That would give you the answer of the above angle, which is the angle S almost. So to get that, we'll subtract. That would give us the 59.3 degrees. It means the angle over here is 59.3 degrees. As we got this angle, what we'll be just doing here, again a straight line it is. As that's a straight line, so we have to just simply again 180 degrees subtract with this 59.3 degrees, and from a north of that we'll be getting the answer, like the bearing from the shape S to the port P, and subtracting it down, that would be 120.7 degrees. In that case, again we know we are getting the answer into the like the three significant figures, so we'll round it up to the three numbers. That would be 121 degrees while rounding it up. That would be the simply answer for this question. So that's how you can apply the bearing techniques. We should know about the north and the angle making to the clockwise. After that, different techniques from the triangle, different techniques from the parallel lines, you can apply them and easily get the answers. Question number 3, that's another past paper question. In this question, grab your protractors and scales for that. That's a very important one as well. Now this question shows two towns A and B are shown on a map. We have been given one town A and another town B, and the north of they have already been drawn. The north of both the A and the B are drawn. They are giving the scale of the map is 1 centimeter to 3 kilometer. It means that on the map, if they're showing, like on this scale diagram, they are showing 1 centimeters equal in the real distance of the 3 kilometers. So this 1 centimeter shows on the real distance is equals to 3 kilometers. What we are finding out is we're finding the actual distance. It means we're finding the real distance between A and B. To get that real distance, what we have to do is we have to first of all calculate how much centimeters is it going to be. And to get that, I have opened a scale here. So starting here from the 0 centimeters, and we'll mark it out how much centimeters it would be. As that's a 0 centimeters, if we mark it out till there, how much it is? It's going to be 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, and within, you can say closely to the 12.5 centimeters or 12 yeah, it's going to be almost 12.5 centimeters. So we have got this thing. This whole line is 12.5 centimeters. You can measure it from your scale as well. There is a somehow like a bound that we can say there would be 1 centimeter above or 1 centimeter down. You'll be getting the marks for that, because this is like the error you can adjust in that. So now finding the actual distance, we know it's a 12.5 centimeters. There's a very easy technique. We know 1 centimeter is equals to 3 kilometers. And what we are finding out? We are finding out from the actual distance x kilometers, and for which we are finding out it's 12.5. It means one is this. So for finding out the kilometers in that, we'll just doing the cross multiplication thing, or you can just simply multiply this 12.5 by 3. And after multiplying by 3, you'll get the actual distance for that, which would here equals to 37.5 kilometers. It means on the actual distance, like the real distance on the, you can say ground or somewhere, it is 37.5 kilometers. Part B. Measure the bearing of B from A. Now remember the words showing here is measure. Measure means you have to use your protractor for that and to get the bearing from B from A. So first of all, we'll get what is the A, because from A we are getting, so the north of A is this one. From the north of A you're getting to get that here. You have to just use your protractor. You can say, you can put your protractor, it's kind of a D, so it would be like this on your protractor. I'm like showing you here, I cannot get directly the angle here, so that would be kind of your protractor. We know that this would be almost 90 degrees, and if we increase that on approximate, it's going to be 120 degrees. You have to use your protractor and carefully understand it to get the answer. Now it's not 100% accurate. I'm telling you again and again, this 120 degrees, it can be a difference of that. Okay, it can be 110, it can be 130. So you have to use your protractor and get the answer. I'm just showing you the step. And when you measure it, the 120 degrees is supposing the answer. The important part is this part C, that you have to use the technique and you're getting the answer then. Calculate the bearing A from B. Now we know we have already get the bearing from A to the B. Now you're getting the bearing from B to the A. It means you have to go to the north of the B and then get the bearing clockwise towards the A. This is the thing. And when you get it, this would be your bearing answer for that. But to get that, I told you, you can apply the techniques if you are having the back bearing, because B from A is given, you are going to get A from the B. To get the back bearing, I told you if the angle is less than 180 degrees, just you have to simply add 180 degrees to that and you'll be getting the answer. But suppose that angle 120 is bigger, like it's 190 degrees. If that would be a 190 degrees, then you have to simply subtract 180 degrees and you'll get the back bearing. So when you add them both together, it would be 300 degrees. 180 plus 120 is 300 degrees. So it means the back bearing, or you can say the bearing from B to the A, is 300 degrees. And that would be your answer for this one. So these are the 3 questions we have applied. These are the past paper questions to complete this bearing topic. Let me know if there will be any confusion in the comment section. Okay then, see you then in the next one, guys. Bye.